I'm going to start the truck in a moment here, and you can see this thing working live. Some engines won't run properly at all with the mass airflow sensor out in the open like this, because with this thing sitting over here, there's no air actually flowing past it. And so it is going to send a reading back to the engine's computer, but the reading that it sends has nothing to do with the amount of actual air flowing through the motor. So at idle speed, normally at idle speed there's not a massive volume of air going through here, so then there might not be a great deal of voltage going on here, enough obviously for the engine to run. Some engines' computers are also programmed for like a default setting that if this thing is either disconnected or really faulty, or if it's not reading anything, the default setting will basically compute a fuel mixture that allows the engine to run so that you can drive the vehicle and get it serviced, but it will also set a check engine light, and your engine light will go on the dash, alerting you to the fact that you have a fault. But it still allows you to drive. I've seen other vehicles where as soon as you disconnect this thing or take this off the airstream, that the airflow is disrupted so much that this, the engine basically goes into convulsions and shudders and shakes and won't run right. When I fire this up, you're going to hear a hissing noise, and that is air being sucked in here, and I'll show you how much vacuum there actually is. Okay, so it's actually idling not too bad, but there's a lot of vacuum here. And when I lock it off, the motor sure doesn't like it. And I could stall it if I wanted to. So you can see that airflow is being used by this sensor to come up with a fuel air mixture to run the motor at idle. And then as we increase throttle, it is running, obviously, but it's not quite as smooth as it normally is because it's not able to fully compute the optimum fuel air mixture because this thing's not actually in play. Okay, I'm looking at the fuel system now, and I'm going freehand here, so please forgive the wiggly camera. Basically your fuel, in your fuel tank there's a pump. If you think of the sump pump in your basement of your house, it almost is the same principle. Your fuel tank is like the sump pump, except picture that it's completely sealed off and under pressure. And then you have a pump inside it, and the pump pressurizes the fuel and pushes it up to the motor. And it runs through a couple fuel lines, and eventually it arrives at that guy right there. That's called a fuel rail, and all it is a pipe essentially with some outlets on it, and the fuel injectors are underneath them. So if you look down right there, if you see a little bit of the color blue down under there, that is a fuel injector. See if I can get a shot of it. There it is. Okay, so the fuel injector is basically connected to the fuel rail, and there's going to be one individual fuel injector for each cylinder. And the fuel injectors all have signal wires on them as well. I'm going to see if I can catch a picture of the one up at the front here. I'm going to try and get a different one. Okay, hopefully this one shows a little bit better. The fuel injector is right down here. You can see the color red. That's the color of the wiring harness that it's attached to. And so the signal wire comes from the engine's computer. Remember that the air flow has been computed. Inputs from the mass airflow sensor, the manifold pressure sensor, the throttle position sensor, etc. That all gets processed by the computer, and it comes up with a calculation for how much fuel to spray. And so the signal wire basically tells this fuel injector how long to stay open. Okay, the fuel rail is under pressure constantly. Here's the fuel rail right here. And so this whole system is constantly under pressure. And then when the computer says, okay, fuel injector, stay open for X number of milliseconds. That's how long it sprays. And then if your engine speed increases, you're going to have more airflow, obviously. Then that's going to send a signal for the fuel injector to spray a longer, it's called a dwell time. That'll basically give you more fuel to add to the increase in the air, and it kind of keeps that stoichiometric fuel air mixture, matched, identical all the way along. So regardless of how fast your engine runs, the air fuel ratio needs to stay the same the whole time. All right. Of course, we all know what this thing is. I mean, essentially it's a basic fuel injector in a way. If you picture that the signal wire from the ECM tells your hand how much to pull in, which would then increase or decrease how much water sprays out of this thing, it's the same theory for your fuel injector. Okay, your engine has measured incoming air, and it has, as a result of a computer map, it is basically telling the fuel injectors, okay, spray for how many milliseconds and then shut off, and spray again and shut off. That's all timed to your intake stroke, and it's matched to how much air is flowing into the motor. And then of course it's changing all the time based on RPMs. I actually have a fuel injector here. This one is a replacement one that I exchanged out of my car. This is actually out of a direct injection engine. The engine that you see in front of you here is called a port fuel injection system. So this thing, basically, the fuel injector is installed directly into the intake runner or intake port, just outside of where the intake valve is. And so then when your piston's moving down on an intake stroke and your intake valve opens, your fuel injector squirts the appropriate amount of fuel into the airstream as the air goes into the cylinder. That's port fuel injection, because the fuel is being injected into the port. Direct injection is a new modern version of fuel injection. It's much more precise. And the fuel injector is actually installed into the cylinder head itself. And so if you look at the bottom of the cylinder head, you would see the valves, and most engines now have 4 valves per cylinder. You would see a hole for the spark plug, and right beside the spark plug you would see the tip of this fuel injector. I actually have a cap on the end of it. I'll take it off because it's actually compressing the seal. Come here. Okay, this little seal right here is made of a very special material. It's got to survive incredibly high temperatures. You can see some carbon deposits on the end of it. Okay, so from about, well, pretty much from there on down, that extends down into the cylinder, and there's no way the camera will pick it up, but there's a couple of very fine holes on the end here. And so when the fuel injector sprays, it sprays directly into the cylinder. The air has already flowed in there, and this thing sprays right into the middle of the cylinder. It's a more precise loading of fuel into the air-fuel mixture. Your combustion occurs in the middle of the cylinder, very precisely right beside the spark plug. So it's easier to match air-fuel mixture for precise high-power mixes, good fuel economy, etc. It's kind of the new way. Diesel engines have been using this technology for a while. The reason this thing has a cap is because this seal, if I leave this thing sitting around, this seal will expand, and then if I ever want to install it back into the cylinder head, it won't fit. There's a special tool you have to use to compress the seal, or else it'll tear on the way into the cylinder head. And if it gets torn, then on a compression stroke and also on a power stroke, you'll actually have some pressure come up the side of the fuel injector, which will actually burn a stripe into the side of the cylinder head and destroy your cylinder head. So these little seals are a really big deal. So I'm going to put that cap back on before that thing starts to change size. Okay, so in summary, your air comes in from the fender well here, flows through, goes into the air box, travels up through the filter. There's the filter sitting on the dash, and then it goes, well, there's the component over there, goes up into that, through the flex line, through that collector, and then it goes past that little mass airflow sensor right in there, and then in through the throttle body, and the amount of air is measured, and the signal goes back to the engine's computer to tell it, here's how much air you have right now, and then based on that calculation, it makes a message, a signal to the fuel injectors for how long they should spray. A short spray means a small amount of fuel, a long spray means a large amount of fuel, and this calculation is going on, you know, multiple times per second constantly while you're driving, adjusting your fuel air mixture to be as optimum as possible. One other thing I didn't mention, those of you that are familiar with engines that need a choke or a primer to start in the cold, well, the engine also has a temperature sensor, and on this engine it's really easy to find. It's right up front here, this little wire behind the alternator right there. There's actually a fitting that's screwed into the manifold, and the other end of the fitting actually goes right into the coolant. And so when the engine's cold, that temperature sensor is going to send a signal to the computer. I mean, think about that computer. It's getting inputs from everything, and it's making all these calculations according to the input that it gets. So if it gets an input that the engine is cold, then it's going to make an adjustment to the duration of the fuel injector. Okay, keep in mind that when your engine's cold, it needs to have a rich mixture. And how do you give it a rich mixture? Well, you spray just a little bit longer than normal. So even though the mass airflow sensor might say, hey, here's how much air you've got, the computer then also gets a signal from the temperature sensor saying, hey, it's 0 degrees. We just started this engine and it's 0 degrees. So the computer will then go, okay, I know I've got such and such amount of air, but I also know I'm at 0 degrees, which means I need a little bit more fuel. And so it'll increase the duration of the spray of the fuel injector. And then as the engine starts to warm up, the temperature sensor is going to tell the computer, hey, the engine's warming up, and grade by grade, temperature by temperature, the computer will start to recalculate the duration of fuel spray based on the engine's temperature. And when you're finally up to your 195 degree operating temperature, or whatever it happens to be, that'd be a Fahrenheit number, by the way, 95C, something like that. Once your engine's up to operating temperature, then the computer is running, it still collects data from the temperature sensor, but it's not really adjusting for temperature any longer because the engine's fully warmed up. Then you stop, you know, I don't know, go to McDonald's for lunch, and you sit there for half an hour, you come out, the engine's cooled off. Well, you don't have to, you know, pump a primer bulb on the side of a carburetor or pull out a choke or anything like that. The temperature sensor is already sending the new temperature back to the computer saying, hey, we're cooled off, we're down to, you know, we're down to 25 degrees or 10 degrees or who knows what we are. And so again, all these calculations are made for you by the engine's computer, and it will come up with a fuel air mixture that's appropriate to run the engine until it's back up to its running, its normal running temperature. Again, that's all going on all the time while you're running and driving, winter and summer. Just a quick closer look at this fuel injector. I showed you the injector end of it. The body of it in here, actually, there's some electronics inside here, because basically it's like a coil. And then on this side over here, you got a 2-pin connector for the signal wire to go in there. And then this side over here is actually threaded, and that's where your fuel line threads onto. So this thing is installed vertically into the engine. The fuel rail will send a line to the fuel injector here. This will be under constant pressure, and then the signal wire from the computer will connect here, and it will basically tell this thing how long to open and close. This is out of a BMW. These things are a little bit of money. They're typically about $300 a piece. but that's the price you pay for some higher level technology.